All right, welcome back. I hope you grabbed a piece of paper or you found a blank piece of paper. I'm going to go through a couple of examples and we're going to make them progressively more challenging. So these first ones, you should be all right with the first couple, and then it'll get a little bit more challenging, and you'll find once you do a couple of the practice problems in class, then the harder ones that I'm going to end up doing here won't look so daunting. So, deep breath here, give me a chance. I don't have a long enough cord. I'm going to work on one side of the page. I'll move the questions over after. So first example I want to look at is what happens if I put a word in here. What happens if I said math to the exponent 0? So I'm just emphasizing, hey, anything to the exponent 0 will equal 1. Okay? So I can put names in there. Also, I like doing this one. This is one of my favorites to put on a test. If I have, and I'll throw a whole bunch of stuff in here, 3x plus 2 times 4,235,000, and then that's all to the 0. So something really big and ugly. And I'll get people inside looking and figuring out what's going on inside the bracket. But at the end of the day here, if this whole thing is to the exponent 0, it's simply just going to equal 1. So if it's something that looks ridiculously ugly, ask yourself, first of all, is this just one of those trick questions? Just testing, do we know what's going on? Okay, third example. Here's something I also like to throw on there because it tells me whether you pay attention to the rules. I'll put something simple like this on. So 5 to the 4th multiplied by 4 to the 5th. And here's one of those key rules I talked about at the end of that previous video. The only way exponent laws work is if the bases are the same. So I'm trying to trick you here. I'm trying to give you a hard time, making you realize that these are not the same bases. So what you write is cannot simplify. Okay, and I just want to be clear on this. You can calculate this. All right, you can absolutely calculate the answer here with the calculator, but you cannot simplify. This is as simple as it gets. All right, and that's how you leave the answer. Done. Okay. Next. The fourth one, what else will I throw at you? I'll do something like this just to be mean. 2 plus 5 minus 7 to the 0. And right away I get people going, aha, it's 1. And when we do that, kind of the quiz or the homework, whatever, we say, are you sure on that? Because the only thing you have to check for here is what's going on inside. So 2 plus 5 is 7, take away 7. I end up with 0 to the 0. So therefore, my answer is undefined. Okay? So there's 4 examples of some, I won't say hard ones, but tricky ones, because I'm just testing your attention to detail. That's really what I'm looking for here. It's not trying to be mean or anything. I just want to know, do you know your basics? Do you see the finer details? Fifth example here. So now this is when it gets a little bit more challenging. So what happens if I mix up some variables and some numbers? So what happens if we put 2a cubed b squared to the exponent 4? So the first thing I check for, okay, so I got my checklist out. So the first thing I look for is same bases. So I look, is there any same bases inside here? Okay, so I'm taking a peek, a 2, an A, a B, no other same bases. The inside of this bracket is simplified. So this is just power of power, okay? Power of power, and I can't write small, so there you go, power of power. So what does the power of power rule says? Or there's some good English now. It says that every inside exponent is going to be multiplied by that outside one. But here's the trick, or here's what we always get for a common mistake. So I get a to the 12th, which is correct, and I get b to the 8th, also correct. What people forget is the 2 is a person too. Well, it's not really a person, but it's an important thing. Okay, you can't hate on the numbers. Just because the 2 doesn't have an exponent written, we assume there is a 1 there, which means it has the right to be multiplied by that 4. So 4 times 1, so it turns out to be 2 to the 4th. So don't hate on the numbers. They deserve those exponents as well. okay? So just be aware that that outside exponent multiplies each and every exponent inside, okay? All right, sixth example. I'm not going to drag this out too long because it's going to be trial and error. It's one of those things that you practice. It's like a sport. You got to do it a couple times anyway. What happens if you run into 3a squared b cubed c multiplied by 4a to the fifth b c, I don't want to get too much in there to start with, c cubed. So I always ask students, what would you do here? And I mean, based on last semester, they go, oh, just quit. And okay, well, you can't just quit every time you come across something new or different. First thing you need to do is you need to look inside each bracket. So if we look inside each particular bracket here, this bracket, we have a 3a, a b, a c, no similar bases, so that one's simplified. I look inside this one, 4a, b, c, again, everything's simplified. What's happening? I've got two brackets side by side, so we have multiplication. So we can apply our exponent laws to like bases. That means my a's can be multiplied together. So the rule for multiplication, same base, we can add the exponents. 2 to the 5 is 7. We've got our b's, same bases, add the exponent, and just be careful, that b has a 1 for an exponent, so it's a 4. And finally the c, same base, that one also has a 1. We end up with c to the 4th, okay? Then I have students come to me and say, well, what do we do with the 3 and the 4? They're not same bases. And this is where you kind of lose. You start seeing the forest, or see the trees, and you don't see the forest. Well, what is 3 times 4? 3 times 4 is just 12. If it's just numbers, just multiply them together, okay? Don't try to make this more difficult than it really is, okay? And that's all there is to that example, okay? A couple more trickier ones. What number? 7? I always like putting this one on a test because it freaks people out. So 3a to the negative 2, b cubed, c to the negative 5, d to the negative 4, e to the 5th, f to the negative 9. This is only testing your negative exponent law, all right? If you look in here, there are no similar bases, okay? So 3a, b, c, d, e, f, there's no repetition there, so we don't have to apply any laws, okay? Or there's no simplification. All we need to do is we have to get rid of these exponents, these negative exponents. The negative exponents are a problem. So remember when I did the law, I said if it has a negative exponent, it's going to move to either numerator or denominator. So here you go. Does the 3 have a negative exponent? No, we assume it to have a 1. It's a positive exponent. He's happy where he is. A, does it have a negative exponent? Yes, it does. Well, it's not happy where it is because it's very negative. So we send it downstairs, get some snack downstairs in the kitchen. Now the exponent becomes positive. A's a happy guy. B, how's B doing? B's good. He's got his G.I. Joes. Positive exponent stays where he is. What about C? C is very, very grumpy because he's got a negative 5. So we definitely have to send them down to the kitchen, get something to eat. Exponent becomes positive. Okay? I fixed up the top. The top's done. Moving down to the denominator, d to the negative 4. D to the negative 4, also a very negative term here. It's grouchy. You know what? Let's send him up to bed. Goes upstairs to bed, becomes very happy, becomes very positive. So if you change the location, the sign on the exponent changes. E to the 5th, still lots of sleep, lots of food down in the kitchen, so we're happy. Going to stay where they are. F to the negative 9. Negative 9, not very happy. That's way down on the negative scale. Let's make sure we send it F upstairs to get some sleep. There you go. All you're doing is changing the location, numerator, denominator, getting rid of those negative exponents. Okay? All right, let's try number 8. What happens if there's some simplification involved? Okay? So let's go with a to the 5th b squared over c cubed multiplied by c squared, oops, don't put d, we don't have d's in this one, b to the negative 3 over a to the 5th. So this is a point where you're kind of freaking out because you haven't done any of the homework yet, but it's really not that bad, okay? First thing I do is look inside each corresponding bracket, and I see that each corresponding bracket, A, B, C, there's no similar bases in there for me to clean up or simplify, okay? So that means I can go right ahead and start my multiplication. So we did fractions. We know that when we're multiplying fractions, you multiply across the top. So across the top, I have an A. Is there an A on the top here? Okay, I'm talking about over there. The answer is no. So I still have a to the 5th. He hasn't changed. Is there a B? There is a B. So I have to use my exponent laws, multiplication, add our exponents. So 2 take away 3, we end up with b to the negative 1. What about our friend C? Well, there's no other C on top, so it goes as C squared. Now, multiplying the bottom. So remember, we multiply across the top, and we multiply across the bottom. Never done that before. All right. A and C are not the same base, so it becomes a to the 5th C cubed. All right. Now you ask yourself, is there any like terms left? The answer is yes. I've got a pair of A's, so we've got to combine them or simplify them. And I have a group of C's here. So we've got to deal with those. So starting off, let's start with the A's. A to the 5th divided by a to the 5th, so we subtract the exponents. I'm going to write this out. I end up with a to the exponent 0. There's no other B's, so he's going to just stay there by himself. And my C's, let me circle that in red. Always top exponent minus the bottom one. 2 take away 3 is negative 1. Got negative exponents. We can't have negative exponents in our answer. So let's take care of them. So I'm going to leave A for a second here. B, negative exponent. He's hungry, needs to go downstairs. We send him downstairs for food. C's also hungry. It goes downstairs as well. Now what about a to the 0? Remember, anything to the exponent 0 is a 1. And we have to have a 1 left over on top anyway. So the final answer here is 1 over b times c. All right. There's your final answer. Okay. They do get a little bit more challenging in the homework, but like I said, it's a growing experience. You'll find that you get quicker, you get better at them as you go. Okay, this will set you up. You're probably going to spend 2 days on the worksheets in class, getting a level of comfort, and we'll go from there. But good luck. If you have any questions, make sure you ask. If you have any questions about the note, make sure you highlight it, write it down so that I can help you in class tomorrow. All right, good luck. We'll see you then.